The $599 MacBook Neo relies on a hardware strategy rarely seen. Apple bypassed traditional laptop engineering by repurposing a smartphone processor for a desktop-class machine. This strategy allows Apple to avoid the massive research and development costs required for their dedicated M-series laptop chips. As a result, the retail price for this machine is nearly 40% lower than their baseline MacBook Air. To understand the actual utility of this device, we are auditing the thermal limits and memory constraints of this crossover architecture to see where the cost savings turn into performance bottlenecks. The A18 Pro chip inside this machine is manufactured on an elite 3nm N3E node. 3nm N3E is a fabrication process that allows for higher transistor density, which increases processing speed and power efficiency by reducing the distance electrical signals must travel. Porting this mobile system on a chip to a full desktop operating system changes the baseline economic rules of the global laptop market. Two consumer variants are available for this machine: the $599 base model with 256 gigabytes of storage, and a $699 version with 512 gigabytes. All models share a specific baseline: the A18 Pro chip, a locked 8 gigabytes of unified memory, and a 60Hz liquid retina display. The entry-level price requires physical sacrifices. The base model lacks biometric security, replacing the standard Touch ID fingerprint scanner with a mechanical lock key. Further cuts appear in the interface. The keyboard lacks a backlight, and the display is restricted to the sRGB color space, which lacks the professional-grade wide color range found on more expensive Macs. This diagram shows the chassis bandwidth bottleneck. While one USB-C port supports a 10 gigabit per second stream, the second port is choked down to 480 megabits per second. This speed limit makes modern external drive workflows difficult, as file transfers take minutes instead of seconds. Apple reached the $599 price target by reducing peripheral bandwidth and removing premium chassis features while keeping the main processor at full speed. Manufacturing scale is the primary driver of this laptop's cost. Printing tens of millions of chips for the iPhone drives the unit cost down to a fraction of a dedicated Mac processor. The A18 Pro architecture was originally verified and stabilized for use inside this flagship mobile device. This low component cost allows for aggressive pricing, with the $599 base often dropping further when factoring in trade-in values or credit card cashbacks. The pricing is most strategic at the $499 education tier, an entry point designed specifically for students and schools. Leveraging these smartphone economies of scale allows Apple to use high-end silicon to compete directly with budget Chromebooks. This chart shows the single-core performance benchmarks. The A18 Pro generates a score of 3,461, placing it ahead of the M1 and equal to the M3. High single-core speeds make bursty tasks like web browsing feel instantaneously responsive. However, in multi-core benchmarks, the Neo plateaus at 8,668. This result is nearly identical to the performance of the 5-year-old M1 architecture. This performance limit exists because the chip only contains 2 performance cores and 4 efficiency cores. This diagram illustrates the system's primary constraint: swap memory. When multitasking exhausts the 8 gigabytes of RAM, the system moves data to the secondary NVMe solid-state drive. NVMe is a high-speed storage protocol, but it is much slower than active memory. Because the drive reads data at roughly 1.5 gigabytes per second, relying on the SSD slows down multitasking during sustained workloads. The lack of an internal fan creates another bottleneck. During long tasks, the system must thermally throttle the processor, reducing speed to prevent heat buildup. Despite these limits, the low power draw of the A18 Pro allows for 16 hours of battery life, even with a physically smaller internal battery. The Neo prioritizes rapid responsiveness in short bursts, though its lack of active cooling prevents it from maintaining that performance during sustained heavy compute loads. Comparing the MacBook Neo to the current M5 MacBook Air reveals exactly what the extra $400 buys you. The Neo lacks MagSafe charging and high-bandwidth Thunderbolt 4 support, both of which are standard on higher-end Macs. The screen also creates a deficit for creative work. The Neo's sRGB display cannot render the wider color profiles found on the Air's professional-grade P3 wide color panel. Some buyers consider refurbished M1 or M2 MacBook Airs for a similar price point. The Neo maintains a software advantage over those older machines due to its 16-core neural engine, which supports modern Apple Intelligence features. This forces a choice: prioritize modern AI processing speed or prioritize the premium chassis features found on older flagship models. These technical constraints lead to a clear decision matrix for different user profiles. The buy profile consists of students, writers, and casual home users. For these users, the high single-core speed of the A18 Pro provides a fast experience for daily browsing and basic programming tasks. The pass profile includes video editors, photographers, and gamers. For photographers, the sRGB display makes accurate color grading difficult without an external monitor. For video editors, the 8GB memory limit and legacy USB 2.0 port will choke high-resolution 4K file transfers and timeline scrubbing. The 2026 MacBook Neo is a masterclass in supply chain engineering, but to find its true value, buyers must operate within its specific architectural limits.